All right, in the previous video, we talked about momentum. We talked about what that was, and we talked about how basically any moving object is going to have momentum, assuming that that object has mass to it. So today what we're going to talk about is what is required in order to change the momentum of an object. Well, in order to change any type of object's movement, we've already noted that we have to apply a force to the object. Now, you can apply a force quickly, or you can apply a force over a period of time. So as I was trying to think how to explain this to you, I happened to think about my steaming mug of tea this morning, and I was thinking, okay, what would happen if I were sitting across the room from my daughter? And I said, hey, Anna's my daughter. I said, hey, Anna, could you please bring my tea to me? Well, let's say that Anna has a little mischievous streak in her, and so she sets my steaming cup of tea on my office chair that has wheels on the bottom of it, and then she gives it a shove across the floor so it comes straight towards me. Now, I have basically two things that I can do. As the chair comes toward me with my full mug of tea on it, I have two options. I can either stop the chair really quickly, and if I do that, what's going to happen to my tea? Yeah, it's going to slop all over the place, and I'm going to have spilled tea and a wet chair. So I don't really want to do that. Or as the chair is moving towards me, I can kind of grab a hold of the chair and gradually slow that chair down, and then hopefully I won't spill anything. Now, I do want to make a comment that if I did ask my daughter to bring my tea, she would never put it on my office chair and shove it to me, but that was only for purpose of an example. She's really a pretty nice girl. So anyway, that is what we're talking about when we talk about impulse. So I can apply a force very, very quickly in order to change the momentum of an object, or I can apply that force over a period of time. And as you can see through this equation, if I apply the force over a longer period of time, if delta t goes up, then force is going to have to go down if I'm trying to get the momentum that it has to come to a complete stop, okay? So two things you can do. You can apply a large force for a short period of time, or you can apply a smaller force over a longer period of time. So we're going to work together a couple of the examples that are in your book so you can see how to work those. So we're going to look first at example 9.2, and it says, in order to get the necessary range on her drives, a golfer must hit the ball, and it gives us the mass, off the tee so that its initial velocity is 30 meters per second at an angle of 45 degrees. If the ball and the club are in contact for 0.120 seconds, with what force must she hit the ball? Okay, so while the ball is sitting on the tee, it doesn't have any velocity. And so what we're talking about here is we're going to change the momentum of the ball by exerting a force over a period of time. And we know that the club is in contact with the ball. We know what period of time that it's in contact with. So the first thing I've got to figure out is what the change in momentum is of this ball. Now, just like change of velocity is the final velocity minus the initial velocity, the change in momentum is going to be the final momentum minus the initial momentum. So it's the definition of change is the same as it has been when we were talking about velocity. So if I look at my change in momentum, the final momentum is going to be what we have after she hits the ball. So the mass of the ball is 0.0459 kilograms. And it tells us that the velocity is going to be 30.0 meters per second. Okay, so that's the final momentum. My mass times my velocity is momentum. And the initial momentum, since the ball wasn't moving, there was not any initial momentum. And so that initial momentum is 0. So when I work those numbers out, I find out that my change in momentum comes out to be 1.38 kilogram meter per second. Now that I know a change in momentum, I can then calculate the force that was necessary, because change in momentum equals force times delta t. The change in momentum was 1.38 kilogram meter per second. The force is what I'm trying to find out, and the time that they gave me was 0.120 seconds. So if I divide both sides by seconds, what am I going to end up with? Well, I'm going to end up with kilogram meter per second squared, since the seconds is going to be divided. Kilogram meters per second squared is a Newton, just like we learned before. And so if I divide those numbers out, I'm going to end up with a number of 11.5 Newtons. And you will recall that force is a vector quantity. And so since I know the direction of the velocity, which was at an angle of 45 degrees, I know that this force also has to be at 45 degrees. Okay? So in order to calculate impulse, which is what this right here is, this is the impulse, force applied over a period of time. In order to calculate the force associated with that, you have to calculate the change in momentum first. All right, the second part of this problem is going to be similar, although not exactly the same. So we will make some more space up here so we can do the second part of the problem. And the second part of the problem says that a baseball player catches a 145-gram ball that is traveling with a speed of 22.1 meters per second. If the player can exert a force of 55 newtons, how long will it take to stop the ball? Okay, so again, this is the relationship I'm working with, and I'm going to have to start out with finding the change in momentum. So if change in momentum is the final momentum minus the initial momentum, in this case, he's trying to stop the ball. So the final momentum of the ball is 0. The initial momentum is going to be the mass of the ball, which is 0.1450 kilograms. And the velocity of the ball was 22.1 meters per second. Okay? So when I work these numbers out, I get a change in momentum of, and you'll notice that this time it's going to come out negative. So it's going to be a negative of 3.20 kilogram meter per second. I have 3 significant figures here. Okay? Now, because what it's asking me is it's asking me how long it will take to stop the ball. So I'm going to use my delta P equals F times delta T again. Now I know that delta P is negative 3.20 kilogram meter per second. And it tells me that the force is 55 newtons. However, you need to think about what sign that needs to have. Positive and negative signs in physics very often are going to indicate direction. And so if the ball is coming this way, which way is the player applying the force? Well, he's applying the force this way if he's catching the ball. So he's applying the force in the opposite direction that the ball is moving. Okay, so in order to do that, then I have to use a negative 55 newtons, and then I'm going to multiply that by delta T. So if you notice then when I divide that out, that's going to make sense because my time then is going to end up positive. So delta T, when you solve that, is going to end up as 0.058 seconds. So that's how long he's actually going to apply this force for in order so that this ball will actually get stopped. So you will get some practice today working these type of impulse problems.